And we're live. Excellent. Here we are. Wonderful. Once again. Just double checking something online real quick. There we go. Good and good. Okay. So those of you in the chat, I see people have already started leaving comments. I see it right there. There's my crab wave at you in the chat right there. But yeah, we are going to get started with today. I have several things. I probably have a bit more than I need for today. But we'll see what we get to. So first and foremost, I wanted to finish up that pineapple orange cake example. Disgusting, I know, but we do have to finish up that example real quick, just in terms of cake, just because I want to talk about it and how it will play out. Then I have a few different things that I want to try. I have a couple of videos on, believe it or not, a couple of videos about the fair division of a cake. And I don't know, they're kind of weird, but I want to show them regardless. They're shorter videos, I think like 3 or 4 minutes each. And then I do have a quizzes that I want to try as practice that does involve a lot of the techniques and definitions that we have been learning for the past couple weeks in regards to fair division. So that is my general goal for today. Number 1, I want to finish up the pineapple orange cake example. Number 2, I do have a couple of videos that I want to show in terms of the fair division of a cake. Because yes, believe it or not, there have been mathematical studies in regards to the fair division of cakes. It's weird. And then I do have a quizzes that I want you guys to try as practice, just to kind of see where everyone is with the information that we've learned thus far. So first and foremost, very briefly, I'm going to ask for those notebooks to be out and open because I want to finish that orange pineapple cake example, just to kind of recap a couple things from it and just to wrap it up for those 3 who are trying to divide a cake. So let's see what we got here. Boom. Boom. So let's see. Let's just call this, and again, yes, I do see so far 3 comments. Thank you for those. If you guys, again, in the chat, leave a comment if you haven't already. Let's call this cake division. And today is the 5th. Wonderful. So just to recap, David, Dinah, and Cher. I want to draw this little table here. David, Dinah, and Cher. Before I drew 3 circles, I just want to organize them into how they feel about the different types of cake here. Now, as we did last time, David was the divider for a $27 cake, and he divided it into $13.50 and $13.50 because he divided it evenly. And I'll remind you as to how he made that cut when we get there. Dinah does not like orange cake whatsoever. She values it at $0. And she values, the pineapple at 100%. Maybe she's allergic to orange. I don't know. Then Cher valued orange a bit more and pineapple a bit less. I guess they chose David because since he didn't have a preference for orange versus pineapple cake, they let him do the cutting. But as one does, here was the original cake with orange and pineapple, and David made the cut right there. I probably should have embellished it like I did last time, but that's okay. That's where he made the cut. I can extend that cut a little bit just to kind of show there's his cut right there. Now, just assume nicer numbers. Assume nicer numbers in the sense of like thirds and whatnot. Imagine that this is of the orange half. of the orange half, just imagine that this is a third and that this is 2/3. And of the pineapple half, imagine that this is a third and this is 2/3. We're just assuming that that was the cut that was made in order to make the numbers work out quite nicely for Dinah and Cher. So Dinah, as the other divider, because we're doing lone chooser, Dinah, as the other divider, gets to pick the cake, and as we figured out last time, Dinah took this half of the cake right here. Now, we could figure out the value that Dinah places in this half of the cake. We could figure out the value because I figured out the whole third situation. She values pineapple at $27. And since this is a 1/3 cutoff, I guess if you were pushed to guess, you would say that Dinah values this share at, well, $18 and this share at $9, but that's besides the point. Once David and Dinah have their halves, and this is what we did last time, because Dinah picked this half and David was left with this half. Once they picked their halves, they had to cut them again. So that's why I'm going to bring this next little page in. I'm going to do this a little bit more precisely with the time that I have because I have a little bit more time. So here's David. This is David's side. Now, David does not care. Does not care whatsoever. Most of that half that David has is orange, but he doesn't care. So David is going to cut it into equal thirds because one way or the other, it does not matter to him. He's just going to cut it into equal thirds. Dinah, on the other half, she does value pineapple, obviously, a bit more. And most of this Dinah half is pineapple. So if she was going to attempt to do equal shares of this, her slices would be a bit farther off, something along the lines of this, where she might cut it like that, and then leave that big slice off on the end. The reason for that is because that big slice does have some orange on it, and, well, Dinah doesn't care for orange, so she values that at nothing. So she's really just dividing up the pineapple's parts of this half. So then comes Cher. Now remind me, what does Cher value more, orange or pineapple? Yeah. So in this case, here comes Cher. Cher, move this up a bit, has to pick 2 slices, one from David, one from Dinah. There we go. So what is Cher going to pick? Cher has to put her stock, or not, she doesn't have to put her stock, but she wants to put her stock in a mostly orange cake. So logically, Cher is going to pick these 2 right here. Cher takes 2 subshares. David and Dinah keep the leftover. Obviously, it seems like a weird way to go about dividing a cake, but there are certain assumptions that we are making. You know, people are playing fairly. You know, you're not giving special treatment or selfishness. I'm going to take all the cake. No. Okay, you can have all this cake. No, everyone's going to get a fair share according to what their opinion actually is. This is lone chooser. because share was the lone chooser that ultimately got to choose 2 subshares, and David and Dinah got to divide their halves accordingly. Again, convoluted method. It's weird to think. You guys haven't been to college, but do you know what most college professors, like what their job is besides teaching? Do you know what most college professors do on a day in, day out basis besides teaching? They do research. The college basically is paying them to do research into the field that they are studying. And as a side, they're teaching the next generation of people who will either get bachelor's or master's or PhDs or whatever. So if you can imagine, colleges have paid these doctorates of mathematics tons of money to study how to fairly divide a cake. It's pretty sick. So now that this whole David Dinah share situation is taken care of, I want to show you this first video on actually dividing cake. It's really weird. It's short, but you'll see what I'm referring to. So let me bring this thing up here. It's this one. And this one. There we go. I'm going to bring up the microphone up to the speaker so you could hear it a little bit better. And I'm going to turn the speakers up so you could see it. But let's just see what the heck is going on with this fair division of cake.
We've got a cake. We're going to cut it. Now, if there was 2 of us, as there are, this is quite simple. You just, one person cuts, the other person chooses. It's all nice and fair. No one's envious. Perfect way to cut a cake. A lot trickier, though, when you have 3 people. We've got 3 people. Alice, Bob.
Now, one quick thing. She's about to describe a method that I am not very happy with, but in reality, it's technically a more fair method of going about things. It's just not something that we're going to have on like an assessment or anything.
And Charlie, and they're going to share this cake, and we want to make sure that it's as fair as possible, and that at the end, nobody is envious of anybody else's cake. Turns out there's a very good way to do this that's actually quite recently discovered, and I'm going to try and talk you through it. So Alice goes first, and Alice gets to cut the cake into 3 pieces that she feels are equal. So she would be happy with any of those 3 pieces. Oh gosh. Okay, I'm going to go there. Thing is, I've got a get out jail free card because it's a fruit cake, so I can just claim that there's more fruit in one side. That was what I was aiming for. It's not bad. All right. Okay.
I think I can see the dud piece, but
which one's the dud piece?
I think that's a bit small.
No.
Oh, you have that one
more
then?
Sparkly bits on it. Yeah, absolutely. There's more to a cake than just size. Some people like the sort of crusty bit around the outside. Some people like the sugary bits. Some people, hate the fruits. It's your personal preference that comes into this as well. Okay, so Alice has cut the cake into 3 pieces where she wouldn't mind which of those 3 pieces she got. Now it's Bob's turn. So Bob gets to pick which he thinks are his 2 favourite pieces. Now, you there said that one was the rubbish piece. So let's kind of leave that one to one side and assume that Bob goes for one of these 2. But Bob, from those 2, says which he thinks is the best piece of all. And let's imagine that Bob thinks this bit's the best bit. Now what Bob has to do, he gets the knife now. And Bob gets to cut a little trimming off of his favourite piece until his favourite piece is now equally as good as his second favourite piece, right? So that little trimming kind of goes to one side there. So now Bob doesn't mind between getting this one or this one. It's fine. He's happy with either of those. Alice is sort of sitting to one side, desperately waiting for them to hurry up so she can have some cake. Charlie, it's now Charlie's go. Charlie gets to pick which piece of cake he wants to eat. Have whichever he wants. So Charlie might pick one of the pieces that hasn't been trimmed, or he might pick the piece which has been trimmed. Whatever piece he picks, let's say he picks this one here, it's now going to be Bob's turn to choose a slice of cake. If Charlie didn't take the trimmed piece, Bob's going to want it because he's already said that that's his top, in his top 2, joint top. So Bob's going to take that piece. So now Bob's happy. Charlie's definitely happy. They got first choice. Bob's definitely happy because that was his equal top 2, and now Alice ends up with this piece, and she's definitely going to be happy too because she cut the cake in the first place and she cut it in a way that she thought that all 3 pieces were equally fair. So that's fine, right? So that's the majority of the cake sorted. Now we have to deal with this trimming, which looks a bit pathetic.
You can't just toss that though. There's
no
waste.
No, that's wasteful, Brady.
All right.
No, because Charlie went last on the first main cake cutting section. Charlie now gets to go first on this bit. So Charlie gets to cut this trimming into 3 pieces so that he thinks that each piece is equally as good as the others. Okay, now once he's done that, now Bob gets to pick which of those pieces he wants. Let's say Bob goes for this one here. Now, Bob is definitely happy because he's got his number 1 choice out of the trimmings, and we already know that he's happy with his main chunk of cake. Now it's Alice's go, and whichever one Alice picks, she's definitely going to be happy because in the very beginning, she thought that all 3 of the pieces of cake were equally good. She's ended up with one that hadn't been trimmed off, and now she's got an extra bit, so she's definitely going to be happy. And then finally, Charlie ends up with the last silver trimming, and he's definitely going to be happy too because he cut the trimmings in a way that he thought that they were all equal. So there you go. That is envy-free, totally fair, and totally delicious cake. There is actually an N-person version of this algorithm. The only thing is the number of cuts that it takes to get this sort of envy-free solution gets a bit bonkers.
Yeah, so what do we start getting? Trimmings of trimmings?
Trimmings of trimmings of trimmings of trimmings of trimmings, trimmings, trimmings. So in general, the number of cuts that it takes to divide a cake between n people fairly is n to the 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 n. Which is kind of bonkers.
It is pretty insane that people would put that much effort into fairly dividing a cake. But like I said, in reality, it's the weirdest things in mathematics that end up applying in real life. For example, you guys know what prime numbers are, right? Yeah, prime numbers, I got to tell you, for generations, prime numbers were just considered useless. What application does prime numbers have? What application does cutting a cake actually have? But in reality, it wasn't until the 1970s that they figured out what prime numbers could be used for in a very positive way. Have you ever bought anything online? Have you ever been afraid that somebody is going to steal your information after you've bought anything online? You have? Yeah. Do you know why you can rest assured for the most part? For the most part. You can be rest assured because the way that they encrypt your information online is actually using a system of prime number theorems that were discovered over 500 years ago. They apply these prime number theorems, and now you can buy stuff online and you relatively don't have to worry. Relatively, mind you, obviously there are still ways around it, but you don't have to worry about people stealing your information. Dividing a cake, it's just like, well, how in the world could theorems about dividing cakes potentially impact the world in a positive way? Well, I mean, I don't know. Are there any countries in this world that are arguing over who gets what land or something along those lines? Are there, gerrymandering within the United States, the Middle East, Ukraine and Russia? Just people arguing over bits of land that they have to divide? Not necessarily equally in terms of landmass, but in terms of, well, what's going to make everyone happy? It's just an interesting thought. I have one more. I found it very interesting. It's not about fair division per se. But
who doesn't like birthday cake?
But it is about cake. So I just wanted to show this one real quick.
And what I'm going to show you today is that there are good ways and there are bad ways of cutting a cake. And the classic way, the bad way, is like this, which would be normal. You put the knife in the center, one bit of a slice, another bit of a slice.
That's like the classic.
It is the classic, isn't it? It's almost like a pie chart. You know one thing about the word pie chart? In France, they call them camembert, which is like a cheese. So it's actually like a cheese chart in France. Interesting cultural differences in maths speak. So this is what you would do. You take this, you would put this over here, you eat it, and then you leave this in the fridge overnight. And the reason why this is a really bad way of cutting a cake is that these bits here are just going to get dry.
Have you ever had a birthday cake that you just left in the microwave or the fridge, and after a couple of days, it's hard as a rock? That's what I'm saying. Believe it or not, people have actually taken the time to mathematically study the the proper ways of cutting cake.
And so when you come the following day to have your cake, you do another one, another slice like this. This side here, lovely and soft. This will be dry and horrible. You're not maximizing the amount of gastronomic pleasure that you can make from this cake. There is a better way, a way that is more than 100 years old and was discovered or invented by one of Britain's most famous and brilliant mathematical scientists. This is a copy of Nature, the famous science magazine from December the 20th, 1906. And in the letters to the editor here, it says, the headline, "Cutting a Round Cake on Scientific Principles." The ordinary method of cutting out a wedge, he writes, is very faulty. What he suggests is, and he gives an illustration for it, the proper way, the scientific way, the mathematically perfect way of cutting a round cake, and it is as follows. So we have another cake. The first slice will be like this. It's breaking all the rules of cake etiquette. Perfect. Okay, so this is the first one. And then I need to find a way of taking it out. Okay, we can stick that there. And that has got to be the prime, that's the prime steak of that cake, isn't it? It's the T-bone cut. Here, what we need to do, we need to close the cake together like this, and that's going to come apart. So look what I've got here. I have got some rubber bands to make sure that stays together. The following day, all the flesh, the sponge, is going to be nice and soft. So how do you do the second slice? The second slice, I guess it's not your birthday anymore, so you're not going to have one that's quite as big. It'd be interesting to work out the actual proportions. This is, and you get a lovely breaking of the elastic bands too, which is exciting. This is slice 2, or it actually is slice 2, which has 2 slices, 2 parts. Good. So we put this back together, and we can keep on going. Obviously, I'm going to want to use the elastic band to put the cake. Yeah, that is perfect. That is going to stay so fresh for day 3. Day 3. How should we do day 3 again? Let's turn it around. I think this is going to be the slice for day 3. Again, the satisfying snap of the elastic bands. And I don't know if you've thought about it before, but these triangular slices are really annoying anyway, because it's not very satisfying. Having a nice uniform slice like that is a lot better. So here we go again. This is at the end of day 3, there's 4. And this is going to be perfect. And gradually we are slicing it. Keep on going. I think for the mathematical loners who don't want to share their cakes, it could be useful for a bit more of it.
I just thought that was incredibly messed up. It's like, who would spend all this time figuring out the mathematics behind cake cutting? But they did it in 1906. I don't know. I think this is one of the downfalls of COVID. I think today or either today or Tuesday would have been the day that I would have brought cake in. But unfortunately, I can't in the age of COVID, because Skittles are one thing. They're wrapped up in a plastic bag and they're safe. We can sanitize. But with a cake, it's like there's a lot of exchanging of I got to cut the thing. I got to wear plastic gloves or something like that to cut cake. Oh, maybe I'll do that. I don't know. Anyway, if you would, ladies and gentlemen, if you would, I need you to get on them Chromebooks if you haven't already. I have a quizzes that I want you guys to do. I have a quizzes that I would like you to knock out for me, a practice quizzes. And there is my code right there that I want you guys to use to get on this practice quizzes. I figured out a way. I don't know if it was this class or a different class. I figured a way to get the code to actually show up where it's supposed to. 51002, boom, there's the code, just in case you can't see it. Wonderful. Log on to that thing. That'd be fantastic if you would. While you guys are logging on, I will tell you one quick thing to help you with a couple of questions. There are a couple of questions that talk about discrete versus continuous. Discrete versus continuous. Discrete would be like the Skittles. They are countable. We're not supposed to cut the Skittles in half, but we can divide the Skittles amongst groups of people and whatnot. Continuous would be something that is not countable. Continuous would be something that is not countable. Continuous would be like the cake. Because yes, there is one cake, but in terms of the slice that you can make in that cake, in order to fairly divide it, there are an infinite number of different ways that you could slice that cake. And because that is not countable, it is considered continuous. I see you trying to log on. Yeah. You don't get the Chromebook today?
Oh, I do. It's easier.
I gotcha. Whichever works. I'm still waiting for other people online. This is the problem I ran into. When I can't remember when it was. I think it was like the middle of February, where I was doing a lesson and I set up the quizzes, and then I stood here for like 5 minutes. I was like, I got nobody logging on. Eventually one person did log on, but I was like, that makes me mad. Because I got got 4 people right there that said that they're here. They said, I'm here. And I'm like, oh, okay. Well, then log on to the quizzes. Is the internet working?
Yeah.
Okay. See, I don't do a quizzes every day, or I don't do a quizzes every single class period or something like that. But it's like situations like this that make me realize I'm like, yeah, people are here, but they're also not here. I see it spinning. So in terms of getting this particular quizzes done, obviously it's going to be dealing with a lot of the definitions that we've been doing. You can use your notes if you want to, obviously. I think there's minimal calculations that may or may not need to be done with these problems, but we'll see what happens. All right, well, I don't know what happened to all these guys online. They've all broken my heart, and they're all getting red stars. I don't know what's the opposite of a gold star. Not getting a sticker. You're not getting stickers. Okay, I'm gonna start this thing, and if they realize that I'm doing this, they could always join with the code that's at the top. Let's get this thing moving. Ta-ta! Oh, I gotta lower that volume. There we go. Tell you what, for the time being, I'm gonna freeze the screen. Ta-pa! There we go. There we go. Sorry, I'm just checking the Cali report. Yeah, remaining stagnant. Okay, let me unfreeze the screen here. Flip over to here. There we go. Okay. Let's take a look at a few questions. Let me order them by accuracy. There we go. And let me get down to the bottom here. Okay. Let's talk about a few of them here. I just want to have them high on the, well, not high, but larger on the screen so you can see it. One person cuts and the other person selects in which continuous fair division scheme. This is just our original method right here, divider chooser. Was this a select all that apply problem? Okay, that's why. That's why that ended up at the bottom. Clearly, you guys picked divider chooser method, but then you picked these other. In lone divider and lone chooser, it's not as simple as just one person cuts and the other person selects. In lone divider and in lone chooser, you have at minimum 3 people. You have at a minimum 3 people. So it's not just as straightforward as divider chooser. I haven't talked about last diminisher at all, but that's definitely more than 2 people. It's not nearly as simple as one person cuts and the other selects. And same thing with method of markers. I am going to teach you those eventually, but those had nothing to do with just one person cutting and the other person selecting. That was just divider chooser. The most, well, not the most straightforward, but the most common one that they have. Go back here, boom. I think this was another one, yeah. Which of the following is in an estate division are discrete items? Discrete items. A house is definitely a discrete item. Typically, you can't cut a house in half, like a skittle. You can't cut a skittle in half. Same thing with a watch. Same thing with children. Cake is definitely, as we talked about, a continuous object or item or something like that because you can cut it in an infinite number of ways. Same thing with soda. You could pour out a soda in an infinite number of like heights or volumes or something like that. A house, a watch, a children, you can't divide them. You can't cut them in half. They are considered to be discrete items. Same thing with the Skittles. Although several people did suggest cutting the Skittle in half, but can't do it. You guys know the story of Solomon? Cutting the child in half? You not know the story? Or like Solomon was considered incredibly wise, and these 2 women came to him one day with a baby, both claiming to be the baby's mother. And he's just like, huh. And they're just like, yeah, it's my baby. Give me the baby. They wanted one woman actually was the baby's mother, and the other one wasn't, but the other one wanted the baby because of the money that she would get as a result of it or something like that. So Solomon's just like, all right, fine, cut the baby in half, and everyone's like, what? And so the one woman's like, no, please don't do that. And the other woman's like, go ahead, cut him in half, and Solomon's like, well, clearly you're the mother, the one who said, no, don't cut him. It's a silly story, but it's like, it just, at the time, it was original, But anyway, back to this. Click. Which of the following are continuous? Which of the following are continuous? Money, yes, technically down to the penny, but you can cut that in a number of different ways. Same thing with water, same thing with pie. You can't cut a diamond ring in half. You can't cut a dog in half. So that's what that thing typically comes down to. Thankfully, none of you picked dog or diamond ring. Do you guys know about the C's of diamond rings? You know about the C's of diamond rings? You got to learn about that one day. I mean, all guys typically have to, not all guys, but shut up. Anyway, back to this. Now, this is interesting. This is the type of problem that I have not given you before. I just really wanted to see what you guys thought about this. Brenda and Eddie buy a 12-inch half ham, half turkey sub sandwich for $4.80. Eddie values ham 3 times as much as turkey. Now, the rest of the question is a little bit farther below. I'm going to scroll to that in a moment. But first, let me just draw this thing right here. It's a 12-inch half ham, half turkey for $4.80. Eddie values ham 3 times as much as turkey. So for Eddie, if you were talking ham versus turkey, if he values ham 3 times as much, then you have to figure out an amount of money that's 3 times larger than the amount for turkey, but adds up to $4.80. It's like something like this. It's like, okay, you'll have a calculator. What's $4.80? Oh, you can do this in your head. What's $4.80 divided by 4? Divided by 4. $1.20, right? So turkey is $1.20, and multiply that by 3. $3.60. Just right off the bat right there. That adds up to $4.80, right? Yeah. The way that I did that, I actually did it quite easily in my head. If he values ham 3 times as much, that means that ham would be worth 3 shares and turkey would be worth 1 share, and altogether that's 4 shares. So I just took $4.80, cut it by 4, and that's how I got each of those individual shares. Let me scroll down a little more. What is the value of 1 inch? 1 inch of ham to Eddie. Well, here's the deal. How many inches of ham are there? Do you remember? Well, 12 altogether. So how many inches of ham are there? Yeah, so there's 6 inches of ham. And he values ham at $3.60. So $3.60 divided by 6, I believe, would give you 60 cents per inch. Now, again, we never did a problem like that. I wanted to see how you guys could actually handle that one. That one's a bit tougher if you have no idea how to even conceive of this problem. But that's the general way of going about it. You got to figure out how much ham is worth to Eddie, and then you cut it by 6 for the 6 inches. We will get more practice with that kind of stuff. Again, this was just I wanted to see where you guys were at. Oh, perfect. Yes. Angela and Ben want to divide fairly the strawberry chocolate cake shown below. Okay. Scroll down. The total cost was $6. Angela values strawberry 3 times as much. Ben values chocolate twice as much. Okay. Yes. Angela versus Ben. Chocolate versus strawberry. Angela values it 3 times as much as strawberry, and Ben values. Wait, no, I think that was the other way around. Let me double check that. I'm gonna scroll down. I'll make sure I get these numbers right. Okay, she values strawberry 3 times as much. 3 times as much. And Ben values chocolate 3 times as much. And the cake is worth $6. It's a very similar thing to the turkey ham sandwich. Very similar thing to the turkey ham sandwich in terms of figuring out these prices. I believe the whole cake was worth $6. Yes, the total cost was $6. And then the question is, in Ben's eyes, the piece shown below is worth what? Oh, okay. I see what they're saying now. The whole cake is $6, and there's a piece there. Okay. So the whole thing is $6. That means that Ben would value the chocolate half as $4, and he would value the strawberry half as $2. So the whole chocolate is there for $4, and half of the strawberry is there for $1, making $5 total dollars. Nice. Did you get that one right? Okay. Because somebody got it right clearly, just yeah. But yeah, I love, it's like a weird logic problem. But again, we haven't done anything like that. The only cake that we've done is the pineapple orange one, which again, we'll get more practice on as time goes on. I love it. Again, I want to bring in cake, but I got to make it sanitary. Click. Here we go. Another one. Is it the same thing? $6. Angela 3 times. Okay. Then in Angela's eyes, the piece shown below is worth what? Well, okay, it's the same piece. What's 6 divided by 4? Is that 1.5? Okay, 1.5. $1.50. And then multiply that by 3, that'd be $4.50. I'm going to show you guys all this next week. I'm going to have like these problems back up in our notes and whatnot, so we can kind of get that. But that's Angela. How much is that worth to Angela? Well, the whole chocolate to her is worth $1.50, and half of that would be $2.25. $1.50 and $2.25 is $3.75. Boom. You know what I find funny about the screen right now? Look at the average time. That's what I find funny. It's like, okay, guys, Anyway. Okay. Honest question, is 8 o'clock in the morning too early for cake? Yeah. That's what I kind of figured. Like, who wants cake at 8 in the morning? I got to figure something else out then. Okay. We're going to wrap up with this because we're out of the red problems. We're in the yellow problems, which means most of you got this right. You know what I'm saying? And since most of you got this right, I think we're in pretty good shape from these problems on. And obviously, she's out of the room at the moment, but let me talk about this. 4 friends decided to have a multi-flavored cake, which was jointly purchased for $24. The cake is divided into 4 pieces. The following table gives the dollar value of each of the slices according to each of the 4 friends. What piece of the cake will Justin get? Okay. What do you know about Justin? Yeah, he's clearly the divider. Justin is clearly the divider based on the fact that each share is equal. So we can figure this out. Tatiana prefers slice 2 and 3. Molly prefers slice 2 and 4. And there we go. And Charlie prefers slice 2 and 3. Now, what's interesting about this, and again, what you missed was this. All of these like extra cake problems, like I said, this was a practice. I wanted to see where you guys were at. A lot of these cake problems I am going to be putting into your notes next week, which is why I talked about cake next week. I also asked the question, is 8 a.m. too early for cake? And he said yes. So, I got to figure out what's a good thing you can have like 8 in the morning then. I know, but I can't do that with what I'm trying to teach here. But anyway, Justin, we decided, was clearly the divider. Here's the thing. This multi-flavored cake, do you know how much this multi-flavored cake is worth altogether? Yeah, altogether it's $24. And you can figure that out just based on Justin. He cut about into $6 slices, so that's $24 altogether. Now here's the thing. What is $24 divided by 4? $6 is the minimum fair share. Remember how when it was the 2 of you and you had to have 50% or more? and it was 3 of you, it had to be 33 and a third percent or more. If there are 4 people, it has to be 25% or more, or in this case, $6 or more because of Justin slices. So I'm just figuring something out here. Tatiana prefers slice 2 and 3. Molly prefers slice 2 and 4. I'm only picking the ones that are $6 or more, and Charlie prefers slice 2 and 3. Based on this alone, Molly prefers slice 4, so we're going to put her there. Boom. Tatiana and Charlie are debating on slice 2 and 3. They're debating on slice 2 and 3. So we'll figure that out later with a divider-chooser method. But Justin is going to remove himself from the situation and pick slice 1, which you guys picked clearly. So I was happy with that. Yeah. Oh, I love these problems. I really do. Anyway, I'm going to wrap up from there. We're going to pick up with more of this on Tuesday. Yeah, cake probably is too early at 8 in the morning. What's like a breakfast like? Not a donut, because with donuts they can get a bit messy, especially like the cream-filled ones. But like, what's you guys like? You know what crumb cake is? Like Entenmann's. I gotta think of something, because I don't want to do like regular cake, like chocolate and vanilla cake. I think that'd be way too much at 8 in the morning. You're probably right with all the frosting. I used to teach this class a little bit later in the day. But anyway, I'm going to wrap up from there. Bell's going to ring in about 2 minutes. I'm going to sign off for those of you that are in the chat. And, well, for those of you that are left in the chat. And I'll see you later.